of course, we're looking at chapters 14 and 15 today. And so 14 is the theory about routing, and then 15 is actually 15 is about static routing. So I've got a topology here that I've configured all the addressing. So that's actually what the top of this document is just how I configured the addressing. So I've done IPv4 and IPv6. And so, of course, I had to do the unicast routing command to get the IPv6 working completely on the router. And so I've just done the addressing. It's as per the markings on the packet tracer. And so everything is addressed. The hosts are addressed, the routers are addressed, everything's good. Except for one thing. Of course, the routers don't know the routes on the other networks. And so, of course, router 1 has this Ethernet and this serial directly connected. Router 2 has the 2 serials and the Ethernet connected. And router 3 has 1 serial and 1 Ethernet. And so this only has 2 in its routing table. This only has 3. This only has 2. And so, of course, there's a total of 5 networks and 3 LANs. And the routers only know 1 LAN each at the moment. So if we look at the routing table and show IP route, it only knows the 3. Oh, God, I hate this. Thank you. So it's only got 172.16.2.0, which is a WAN link. Of course, on serial S010, and it knows 172.16.3, and that's the LAN. And so if we looked at the other routers, it'd be identical, but of course there's also the IPv6 we should be looking at, but the situation will be similar there. So it's got a directly connected route for a CAD2, which is again the serial link. It's got a directly connected link for a CAD3, which is the LAN that's directly connected, but nothing else. So, yeah, so the hosts will not be able to ping one another. So, of course, this host is 172.16.1.10, so I'll try and ping it from here. Desktop. And yeah, my router sees the destination of 16.1.10 and goes, I don't have a route for that. And so my router replies back saying, sorry, and that host is unreachable. So we need more information. So there's 3 routers, and so I've got 3 sets of set up here. Now, what I'm doing on router 1, I'm using next hop type IP addresses. On router 2, I'm going to use exit interface instructions. And on router 3, I'm going to use the default route. Now, the IP route command, of course, is how you put in an IPv4 route. And then you put in the destination network, so 172.16.1.0. That's what I tried to ping, but my router didn't know how to find it. So it will know how to find it after I put this command in. You need to supply a mask as well, so it knows how long the network number is. And then you need, of course, to give it instructions on how to find that destination network. And so the next hop is the IP address on router 2. So on the serial 172.16.2.1, what did I do? There we go. And so that is the next hop on the path, basically. So, of course, I'm also putting in the instructions for this LAN, so 192.168.2.0. So again, destination, mask, and of course it's got to go the same way. It's got to go via router 2 to get to router 3. So those are IP route commands with a next hop IP address. Now, of course, we've got IPv6 we need to do routing for as well, and so the command is IPv6 route, funnily enough. Again, you need to specify a destination network. And so, of course, we've got a CAD1 there. And so, of course, these 2 columns mean fill in the blanks with zeros. And then, of course, we don't use a subnet mask with IPv6. It's a prefix length. Now, because I'm using a link local address, so FE82 is actually, does it show us link local addresses on here? No. Well, that's what I set for router 2. So up here, if we look at router 2, I actually did set the link local address of FE82. Now, because that's a link local address, it also wants to know the interface. And so that's why it's got the interface as well as the next hop. All right, so that's all we need on router 1. Let's paste it in. Don't see any errors, no warnings, no nothing, so all good. So let's do show IP route. And so you can see we've now got a static entry for 16.1 as well as 192.168.2 network. So that router actually knows all it needs to know. Now, have we fixed a lot? Not really, because router 1 is the only router that actually knows about the other networks. So I can try pinging that host again. It will be a little bit different because router 1 knows what to do with the packet. It will actually make it to this PC because it says, oh, well, I know how to find that. It's there. And of course, the router 2 is directly connected to it. So it knows how to find that network. So it actually will get to the PC. But when the PC replies, of course, the destination is 172.16.3 and router 2 will go, well, I don't know how to find that. And so that's what's timing out. Because the router that actually has encountered the problem doesn't actually know how to talk to the source anyway. So, yeah, that's why it's timed out as opposed to the local router saying, I just don't know how to find it previously. So while we're getting there, there's more work to do, basically. All right, so when it comes to using exit interfaces on on routing commands, that is basically the only difference between the two. So up until here, that route entry would be identical. The difference is you just specify an exit interface. Now, of course, this is for R2. And so, of course, I need to tell R2 how to find that LAN and that LAN. And of course, it needs a different exit interface for each of those routes.
How can you tell what to use, exit interface or next hop?
Well, yeah, you've got to figure it out basically. So of course you've got to know what's connected to what.
If you just don't know, you can just use the exit.
See on Packet Tracer, I can cheat and I can go. Yeah, so you can see that S010 is there. Yeah. So I know that that's the link there, which of course is the one that needs to go to that one. Of course, this one here is S011, I'm assuming. Yep. And so that's why, yeah. So I'm the one who plugged it in, of course, so I know. But yeah, so in the real world, you'd actually have to trace the cables but again, normally you would be the one who's plugging it in as well as configuring it. But yeah. So yeah, you do need to know that information. And so basically this is the only difference between the next hop and the exit interface is just the last part of the command. And so of course when it comes to the IPv6 commands, again, it's pretty much the same syntax, just slightly different destinations. And then of course the exit interface and away you're off. So again, I'll put this into R2. We haven't interacted with R2 yet. Now, because it's an exit interface, you actually get a warning. Now, because they're serial interfaces, there's no problem at all. Because on a serial interface, there's only ever two hosts. There's you and the other end, basically. And so the warning, while useful, is actually irrelevant for a serial interface. But if this were an Ethernet link between the two, it is a valid warning because it needs to know because Ethernet, of course, can have possibly hundreds or thousands of hosts on it. So you actually need to specify the next hop so it knows exactly where that needs to go. So that's why it gives you a warning. Now, so there's no errors there, just a bit of a warning, but yeah, it's not a warning you need to worry about. And the two IPv6 routes went in nicely as well. So if you look at the routing table, show IP route, you'll notice that we've got a static to the LAN hanging off of R3. And there's also the static to the LAN hanging off of R1. So now if I try that ping, it actually should work. Because it knows how to find that host. And of course, also router 2 knows how to find the originating host. So that all worked nicely. Now, that's improved. We've got some two-way communication, but of course, we actually don't know how to ping the host on R3's LAN. So 192.168.2.10. Now, of course, R2 has all the information now. So this packet is, again, probably getting all the way to the host. But of course, when it replies, router 3 is looking at the destination, goes 172.16.3. I don't know that. And so again, it's router 3 that's dropping it. So, yeah. So we're still not quite there yet. So I suppose what we could do, we could also maybe try out, I'm just going to do ipconfig, because I didn't do a static IP address for the hosts. I'll let it auto configure itself. So let's try pinging that IPv6 host as well. And that's working nicely as well. But of course, again, we look at the destination IP address of this one. It's not going to work because, again, it doesn't have, router 3 doesn't have all the information yet. Okay, so how are we doing on router 3? Thought I'd let this finish, but it's taking some time, isn't it? Now, remember I said on router 3, we're going to do a default route. And so the default route, again, is still an IP route. It's actually just a different destination. So we use quad 0 for the destination network and also for the mask. And so, of course, that mask says 0 bits need to match for this to be a match. So that's a very easy match to make. It's not a precise one, but it's an easy one to make. And so, again, it needs instructions. And so I'm using the exit interface. I've also put in the command if I was to use a next hop IP address, but I've got it commented out because we'll only need one. Now, when it comes to a default route for IPv6, so again, it's the same command. Now, have a look at this. This IPv6 command is actually shorter than an IPv4 command. How's that, eh? And so, of course, here we've got 2 colons. So it says fill the blank with zeros. Well, that blank is all of it, so that's 128 zeros. And of course, a prefix length of 0 again means that 0 bits need to match. So that /0 is exactly the same thing as all quad 0 in IPv4. So of course, the instructions are out of that interface there. with the next hop there. And so, of course, that is what that interface is. I've just plugged the similar numbered interfaces into each other to make it a bit easier. So let's have a look at that. So now there's two changes to the routing table here than what would have been there. So of course it had its two directly connected networks. They would have been there the whole time since it booted. But of course we've actually got this static route here. And so it's got the quad 0 destination with a 0 prefix. And of course it's static, and the star means it's a candidate to be a default route. Now, on IPv4 routing tables, you actually get this line here as well. Gateway of last resort is there, and so that just tells you that there is a default route.
Why did the errors the default route without the
This one, because it was an exit interface without a next hop.
Okay.
So it's the same as when we did router 2. It's the same error, basically. So again, because it's a serial link, it's pretty much irrelevant, but it doesn't hurt to tell you. So that is a slight difference. If we look back at the routing table in R2, oops, don't drag it. It actually says gateway of last resort is not set, because I don't have a default route on R2. But I do an R3. All right, let's have a look at the IPv6. And so, of course, this connected and this connected would have been there before, but of course now we've got the static route, and of course it's a default route. Now they don't do the gateway of last resort line on IPv6 for whatever reason, so you never get it. Yeah, it doesn't do the star either. But the difference is that it actually always puts the default route at the top because it's in numerical order.
Yeah, right.
While for some reason it always puts the default routes at the end, as far as I'm aware. So it's a little bit different, but anyway. So, all right, let's go back to this host and ping the host on router 3. That's working nicely. And so this is the host on router 3 for IPv6. And then now that's working as well. So the 67C7 is the one that didn't work last time. Now it's worked. So we have a working routing table for them all. Now, with default routes, handy little beast. Let's just say R3 had another link on it that was connected to, I don't know, the ISP. And so, of course, on router 3, you would then put in a default route saying, hey, you know, the rest of the world is via the ISP, which is, of course, a sensible thing to do. And so that's nice. Now, of course, that's good. R3 knows how to find the rest of the world. R2 and R1 don't yet. So the options are, well, you'd make R2 the default route for R1, and you'd make R3 the default route for R2, and that would work. But later on, when we do OSPF, you'll actually learn that you can actually use routing protocols to advertise default routes as well. And so there's a special command, default information originate, that will actually advertise that default route to the other routers. And so then they would learn it automatically. And the beauty of doing it that way is, of course, firstly, it's less configuration on less routers. And secondly, if the default route were to die, so let's just say the link to the ISP were to die at some stage, well, the R3 would take it out of its routing table, and it would also stop advertising it to the other routers. And so they wouldn't even try and route packets they don't know. So it sort of stops traffic being routed around and then being dumped later. So it's a lot more efficient way to do it.
Part of the first part of this.
What was that?
OSPF.
Yeah, we are going to have OSPF in that first one. So that's the first couple of chapters from CCNA 3. So yeah, we are.
That's before the break.
Yeah. All right. Yeah. Well, there's a few 14 chapters in CCNA 3 we've got to work our way through as well. So, so that's pretty much all I was looking at demoing today. Yeah. So of course next week is troubleshooting static routing, and so that will be the end of CCNA 2, and so the week following will be on to OSPF. Yeah. So has anyone got any other questions at all?